Welcome to academic class, academic daddy's class. This question says a body of mass 20 kg is suspended in air by means of an inextensible, that is string, a string that cannot be stretched, attached to the ceiling. Another cord B is attached to the body and pulled horizontally until the cord A makes an angle 30 degrees with the horizontal. So see, let's try to interpret this question. They said there is a cord, a string that is attached to the ceiling, and there is a body of 20 kg. Now that this 20 kg body is pulled by another cord B until this cord here makes angle 30 degrees. So as it's pulled, this is now the new diagram. This is the cord A, now makes an angle 30 degrees with the vertical, so 30 degrees. This is the mass, 20 kg. So now have B. So that is what this is trying to tell us. So if you go by that, let's say this is A, I can call this point C. So they are now asking us to find the tension, calculate the tension. So tension is simply force, opposing force, or you say force found on a string or a rope. So there's tension here. So I can call this one TAC, tension on AC. Then there's tension here. Let's say I call this one D. Yes, TAC and TC. Okay, let's say I call this one TCB. Let's say I call this part CC. Okay. So let's do that. So let's say I call this part C. Yes. Since okay. So if I want to analyze this now, this will be in such a way that if I have 30 degrees here, 30 degrees. If I extend this, there's 30 degrees here as well. Yes. So if I have 30 degrees there, simply means that by extension, if everything here is 90 degrees, that means I have 60 degrees here. Yes. So and this is 20 kg. There is force acting downwards on this, which is gravity. So 20 times 10 will give me 200 Newton as the force acting downwards. Yes. So I now have, okay, if that be the case, I can now see, trying to resolve this now. Let me draw this here. So I'm now going to be having, if I draw this out well, I'm now going to be having A 30 degrees. Then I have another 30 degrees. Then I have 60 degrees. Remember that this place is our mass, 200 Newton. That is 20 times 10. For gravity is constant, 200 Newton. So that means if I want to now find the force here, this is now B. So this is TCB. This is C. Then this is A. So TAC. That is the tension here is TCB. Tension here is TAC. Okay. Yes, remember. Yes, now see if I extend this. So you see that is the same force here. So I'm just trying to push it together. So if you don't want to call it the same thing, no problem. So sorry. Okay, let's leave it at this. Just at this point, let's not say B is here. Let's keep B where it is. So we don't get confused. So this is TCB. So if we want to do this now, I will say carrying this force now to the vertical axis, which is Y, will mean I'm always going to use the angle that makes with the horizontal. So carrying this to Y now will be TAC sine 60. And you remember that principle of equilibrium is that force upward must be equal to force downward. And notice that downward of this, the force here is 200 Newton, so equals to 200 Newton. So I can say divide both sides by sine 60 degrees. So TAC is equals to 213.94 Newton. Alright, so let me get the force here. If I want to get the force here, I'll say there is tension here, but I don't know it, so I say TCB. I can see, let me call this point D. Let me not confuse it. Let's say I call this D. So I can say TDB is equals to, now what force is acting this way? If this is this way, you can see that there is no force this way except for this side, this one here. So that is why I was choosing to say, let me take this, that this is the center of this, and I have this. So the force acting this way, it will be on the left hand side, that is the right, is equals force acting this direction will be equals to force acting this. So I'll have here 0 plus this particular one, which is resolving this TAC to x axis now will be, since I did to y is sine, resolving to this will be TAC cos 60 degrees. So that this now becomes TDB is equals to TAC is 230.94, so cos 60, anything plus 0 is that thing. So by the time you do it, TDB is equals to 115.47 Newton. So this is how to go about it, solving it using sum of forces in the y-axis, upward force equal to downward force, and then using sum of forces in the x-axis, that is anti-clockwise force must equal to clockwise force. But if I don't want to do it this way, I can actually use that our method, the method we used in class, which is, I can say, just as I've drawn this now, I'll ask myself, look at, let me draw it again. Looking at the question, let's draw it again. Here's the question. So if we project this to be the rope, and we'll have this to be our object, which is 20 kg, and we'll see that there is force acting here now, 20 kg, force will be acting downwards, which will be 20 times 10, which is 200 Newton. So now this is our TAC, because here we called here A. Then there's angle of 30 degrees, and then we later got everything. If that is the case, that there's 30 degrees acting here, then we later got here to be 60 degrees. Okay, then we now say that there's force acting here, which we call TDB. It's B here. So what we'll simply say is, if this is 90 degrees and we now got 60, what is now the total force from this end to this end? So it will simply be from here to here will be 90. So that is here, here will be 90 degrees. So 90 plus 60, if you carry 10 and put here, it's 100. So it will be 150 for everything here. 150 degrees. Okay. So now, what will be the force here? Everything from here to this point, that is this way, will be 90. Then there's 30 here. So 90 plus 30, 120 degrees. Then everything here will be 90 degrees. So what we can just do is to see this force that I'm seeing here, in as much as it's 200 Newton. But if I look this way, okay, let me start with this one. This force I'm seeing here, in as much as it's this way, everything here is this force TAC. Everything on this now, is actually, see how this thing is looking now. So we've gotten this side to be 150 degrees. If you like, don't develop spiritual eyes. Come and be doubting it. You need to be looking well and be a person that is not hard to agree to something. You will now see what I'm doing there. 90 degrees. So notice that this side is facing this angle, and what I have here is 200 Newton. Then let's say I don't have this one. I have this one because they gave me kg and force of gravity is constant. Then this is TDB. I don't know. I can call it TCB, but we'll call it TDB there to avoid confusion. Then that means I'll just say this side is facing 120, so I'll say I can say 200 Newton all over sine 120. You can also say, if you want, you can also do your own, like maybe sine 120 all over 200. So it's equals to TAC facing this angle sine 90. Notice that it's pointing this way. It's pointing this way. And this one is pointing this way. So equals to TDB is pointing, that is, everything is pointing towards 150, so sine 150 degrees. So this is an easier method to go about this. So when you do it, you now come and carry it. So 200 over sine 120 is equals to let me do TDB first. Whichever way you want to do it. Okay, TAC over sine 90 degrees. So if you cross multiply, you have 200 sine 90 is equals to TAC sine 120 degrees. When you do this, you will now have that this is the same thing as saying divide both sides by sine 120. Both sides by sine 120 degrees. So TAC should give you, punch it now on the calculator. So punch it, you will have TAC to be equal to 230.94 Newton. Tension on TAC, tension on AC. So let's do for the other one. So this is going to be 200 over sine 120. I'm using this one to equal the linear of it because of the fact that it has the side and the angle. So equals to, for TDB over sine 150 degrees. So cross multiply so that you get TDB sine 120 is equals to 200 sine 150. So divide both sides by sine 120. Sorry, yes, 120. Yes, so this will cancel this. So TDB will be equals to 200 sine 150 should give you 100. So 100 over sine 120 will give you 115.47 Newton. So punch your own, do it, you get the same answer. So thank you. Remember to like and subscribe. So this is an easy method for solving any a simple approach or manual method for solving any work that has to do with equilibrium of forces. So remember, I was stressed doing this. This is the normal method using the concept of equilibrium of forces and moments. So we'll use this.